So good day everyone. I'm the second reporter for today. So my topic is all about graph analysis and I'm Reyes Remiven. So I will continue the topic of Ms. Real about the surface and the subsurface, the runoff phenomenon. So and my topic is hydrograph analysis about the characteristic unit hydrograph theory and Stanton use unit hydrograph synthetic unit and the hydrograph application. So first one is what is hydrograph? So the hydrograph show the two graphs, a bar chart showing rainfall, usually from the storm in the line graph, showing discharge, and from before, during the after a rainfall show the in this graph. So basically the hydrograph showing the ways to which a river is affected by the storm. So this help to is to understand by discharge pattern of the particular drainage basin and to help to predict flooding and and plan to flood prevention is increases. So as we can see the chart below is the peak rainfall, the time of the highest rainfall is the peak discharge from the time when the river increase. So the higher flow, there are some delay. So because it take the for the water to find way to the river. So it's called is the lag time. So the river discharge it is the volume of the water flowing the truth at a river channel. So this is the total volume of the water flowing to the channel. So any given point in it's measured to any time meter or scale or cubics is all cubic per all stand from the cubic water per second. So the next is rainfall. So rainfall is the quantity of the rain falling with the given area and given time. So so the normal base of the flowing of the river start with the rise when the runoff ground of the soil. So the water increase the river is show the hydrograph as the given rising length. So the falling length show that the under of the increasing the river is decreasing amounts. So the rainfall is charged of the river measured that the cubics is cubic meter per second. Then the participation of the measured is cm or the stand for mm or stand for millimeters. So there are several types of hydrograph which is include. So first one is the hydrograph, natural hydrograph, and the second is unit hydrograph, third dimensionless unit hydrograph, and synthetic hydrograph, and the fifth is downbench hydrograph or special cases natural or synthetic. So first is natural hydrograph. So natural hydrograph is a one record that the steam gauging site in this big fingerprint of the upstairs drainage areas respond the rainfall. So you can see the figure. So this is example. And the second is the unit hydrograph. So the unit hydrograph is a natural or synthetic hydrograph. So presenting of the 1 inch of runoff so uniformly from the watershed during the special time. In the other words, the area of under the graph is actually volume to the 1 inch of runoff. So the third one is the dimensionless unit hydrograph. The dimensionless unit hydrograph or the generic combination of any hydrograph. So the coordinates of basis scales the ratio of the drainage with the respect in the peak discharge in the time relative to the peak relative to the time and to peak respectively. So the fourth is synthetic hydrograph. So the synthetic hydrograph is calculated based on the watershed storm. So characteristic and SCS is soil, land use, vegetative, cover, size, lie, slope, and the time concentration of important water shed. So characteristic. So synthetic hydrograph are used to stimulate the natural hydrograph for managing the watershed. So the fifth one is a dam bench hydrograph. So special case and natural or synthetic. So the dam bench hydrograph represent sudden release of the water from the impoundment due to bench or the followed by the drainage of the surveyor. So this is a figure. So next one is introduction of unit hydrograph. So the unit hydrograph show the temporal change in flow or discharge per unit runoff. So in other words, the the flow stream will be affected or over the time with the addition of the unit head runoff. So the unit hydrograph are useful to produce the predicting the impact, the the precipitation of stream flow, and hydrograph the rule of unit hydrograph theory is flood prediction to provide us estimate and rainfall to result by the given amount. So given amount and the unit hydrograph show the temporal change in the flow discharge to exceed the unit precipitation of the runoff. So types of hydrograph. So unit hydrograph. I can so the unit hydrograph is defined by the hydrograph storm result resulting from the isolated rainfall of the some unit detection. According the uniformly the over the surrounding area of catchment. So procedure or a unit volume is 1 cm runoff. So step to create a hydrograph. So first is select from the record, isolate the single peak instance storm which according to uniformly which catchment have produced the flood graphs with the acceptable runoff to 1 cm, say 8 to 610 cm. So second is select by the flood hydrograph which has result from the unit hydrograph chosen by step 1 above. So next is select next is separate the flood flow from the total runoff. So by the will know base and separate procedure. So next is from the coordinates of the total runoff. So hydrograph at the regular time intervals deduct the corresponding the coordinates or the base to obtain the coordinates of the direct runoff. So divide the volume direct runoff by the area of a drainage basin to obtain the net precipitation dip over the basin. So divide of all of the coordinates direct runoff by the net precipitation dip obtain the coordinates of the unit hydrograph. So lastly is the plot the coordinates of the unit hydrograph against the since the beginning to direct runoff to this will give the unit hydrograph or base of the duration of the unit storm. So during the flood hydrograph, so selected in the step 1 above. So next is element of hydrograph. So element of hydrograph certain the unit. So hydrograph are the first is base width or the T. So the period of direct surface runoff due to unit storm of the unit hydrograph is called the base time or base width. So second is the unit storm. The unit storm of the unit duration So duration of the unit hydrograph regardless of its entity. So third one is a period, unit period. So the time duration of the unit storm. So duration of the unit is a hydrograph. So fourth is lag time or TP. The time from the center unit storm of the peak discharge of the corresponding of a unit hydrograph. So last is precision. So time, precision time. The duration of the direct surface runoff is n to access the net rainfall. So proposition of the unit hydrograph. So first one, unit runoff duration. For all storm or direct entity, the entities, the period surface runoff. So base time, base width, or the base period is the approximately the the same time at they produce the different runoff volume. So the second is the proposition coordinates. For the unit storm of the different entities, the coordinate of the site hydrograph at the any given time. So in the same proposition, the rainfall entities. So next is principle of superposition. So if there is no continuous so storm and or isolated storm of uniformly entity, net certain they will be divided into the storm hydrograph of front of each obtain the coordinates with the approximate with the time lag into the combine the hydrograph. So port is the same distribution percentage. In this the total period of the surface runoff. So time base or base width. So divide into the equal the intervals of percentage runoff the occurs. So during this the period will be the same of all unit storm difference entities. So the instantaneous unit hydrograph or the IUH, the hydrograph study using the instantaneous unit hydrograph provide a good approach by the hydrologic research since the short duration is effect rainfall is close to duration to caused by the instantaneous bursts of rainfall. So using the instantaneous unit hydrograph is also analysis to magnitude of the maximum flood. So there are example. So in this example, the coordinates of a 6 hours unit hydrograph are given to the storm of success 6 intervals rainfall magnitude of 3 and 5 and the 4 cm respectively, assuming the interpretation loss of 0.2 cm per hour and the uniformly based flow is 30 meter cube per second. Determine the resulting the hydrograph and draft it. So in this problem, may given po tayo itong time or at saka itong U, H, O is the hydrograph ordinate. So given din siya ano yung 1 and 2 na nasa column. So sa pag-solve ani natay 0.2 na losses so i-times na to siya sa 6R na interval. So 0.2 times 6 equals 1.2. So 1.2 is the first interval. So 1.2 this one 1.2 and the second is the 3 cm minus 1.2 equals 1.8. So the 1.8 is the second interval. So what? And the second interval is this 6 to 12. 6 to 12. So dito 1.8. And the next is 0.2 losses times 6R na interval minus 5 cm na magnitude. So, so, so equals the rainfall magnitude. So, gawas na siya, no? Tapos, para makuha ang DRH, DRH is direct rainfall hydrograph. So, i-add lang niya siya. Add na to ang 1.8 at saka ito 3.8 na sagot. I-add na siya. So, magawas ang DRH. Tapos, itong 30. So, ang 30 is giving niya siya, ano siya ang katong 30 meter cube per second. Ito lahat. So, pag i-graph na nato siya. So, pag graph, ito na siya. I-graph na itong mga value dito. Tapos, point lang. Point. So, kaning sky blue. So, ano siya katong DRH or katong direct rainfall hydrograph. So, katong red. Kaning red. So, kaning red mo ni ang HO. So, kaning dark na medyo black. So, ano siyang 3 cm. Then, the kaning violet is 4 cm. Tapos, kaning pink is yung 5 cm. So, pato lang. Thank you.